The mole. So atoms are too small to see. They're obviously then too small to count individually. So we count them in groups. And this is a concept that is actually present in your everyday life as well. So dozen is a unit that we use to count things like eggs and donuts, right? 1 dozen eggs is how many eggs? 12. So 1 dozen eggs equals 12 eggs. Why? You ever think about that? Because a dozen is 12 things, right? Could you have a dozen calculators? Yeah. Dozen bicycles? A dozen ideas? It's just 12 things, right? That's a word, a unit, a counting unit that we are very, very familiar with. We're just going to learn a new one today. Here's a couple that you might or might not be familiar with. What's a gross? Do you know what a gross is? Besides being gross.
144.
It's 144. It's a dozen. 12 times 12 is 144. So if you have a gross of pencils, that means you have 144 pencils. We often measure paper, like you might need for your computer printer, by the ream. What is a ream of paper? 500 pages. So a ream of paper is 500 pieces of paper. Or sheets, I guess we would call it. It's a counting number. Okay? Well, counting atoms, we're going to use a similar unit, but all of these units, even 500, that number is way too small for what we need. So we use a unit called the mole. M-O-L-E. It's not a small, short-sighted animal that burrows underground, and it's not a sauce. It's mole. It's abbreviated M-O-L, which I think is ridiculous, but there it is. The mole is the amount of substance that contains as many particles as there are in exactly 12 grams of carbon-12. Does the 12 grams of carbon-12 sound familiar? That's what we use to define the atomic mass unit. We said that 12 grams of carbon-12 weighed 12 atomic mass units. That's how we defined it. And so the mole is defined in a similar way. We did not make up these units in a haphazard way. They are defined to be the most convenient, because if you're making something up, you might as well make it up to be easy, right? So 12 grams of carbon-12 has some number of atoms in it, right? That number of atoms is the unit for the mole. This is sometimes called the chemist's dozen, because it works just like dozen. A dozen atoms is 12 atoms. A mole of atoms is a particular number of atoms. What is that number? Here's the number. 6.0221418 times 10 to the 23rd. That's the number of atoms in exactly 12 grams of carbon-12. How did we figure that out? That was determined experimentally. This is not an exact number. As it's written here, it has 8 significant figures. That's a lot of significant figures, but it's not an exact number. This is called Avogadro's number after the scientist Amedeo Avogadro, whose work led to the determination of this number. It is given the symbol N sub A for Avogadro's number. Many of the calculations that we do just on a kind of an everyday basis only have about 4 significant figures at the most, and so we usually round Avogadro's number to 4 significant figures. 6.022 times 10 to the 23rd. This is a number that you need to memorize. 1 mole is 6.022 times 10 to the 23rd things. You can have a mole of atoms, a mole of ions, of molecules, of formula units. You could have a mole of softballs. If you had a mole of softballs, that would be 6.022 times 10 to the 23rd softballs. That many softballs, the volume of that would be about the size of the planet Earth. You know how big a softball is? It's a little bigger than your fist. That's a big number. It's a really, really, really big number. It's a mind-bogglingly big number. So if we wrote it in decimal form, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That many. It's a really, really big number. So the mole is 6.022 times 10 to the 23rd particles. Now I have to tell you a story. So you've probably heard of Pi Day, right? Pi Day is March 14th, 314, 3.14, 159, blah, 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 is the value of pi. So mathematicians have fun with Pi Day, right? And Star Wars fans have fun with May the 4th. May the 4th be with you, right? Well, chemists have a day also. It's called Mole Day, and it's October 23rd. So Mole Day is 10/23, 10 to the 23rd. And if you're going to get really crazy about it, it's actually celebrated from 6:02 a.m. to 6:02 p.m. Mole Day. So I'm a chemist. My husband is a chemist. Our 4th child was born on Mole Day. That was just the icing on the cake. That was too fun. So he was born on Mole Day, and he weighed 10 pounds, and he was 23.5 inches long. The only thing that could have been more perfect is if he had arrived at 6:02. There's some things that you just don't have control over. It was more like 8:30, but we tried. Anyway, we actually asked the question, should we give him the middle name Avogadro? And we very quickly answered no. That was going a little too far. But anyway, so I have my mole baby. His name is Michael, and his middle name is not Avogadro. Okay, so we really, really need to understand the mole. And this is something that students, I don't know, it just doesn't quite sink in. So let's look at some questions here. How many bicycles are there in 5 dozen bicycles? 60. Okay, how did you do that? 5 times 12. So let's use dimensional analysis and write it out. So 5 dozen, and we know that there's 12 things in a dozen, right? So there's 12 bikes in 1 dozen. So the dozens would cancel out. We've got 5 times 12. We've got 60 bikes. Does that make sense? You can do a problem like that because you know that a dozen is 12, and then you think about it and you're like, okay, do I multiply by 12 or do I divide by 12? Well, 5 divided by 12 would be less than 1 bicycle, and that doesn't make any sense because I know that 5 dozen has to be quite a few bicycles. So you multiply, right? You can do that one in your head. If you can do that in your head, then you can also learn how to write this down. If you can learn how to write this down, you can do the same thing with mole. 5 moles. How many things per mole? Let's jump down to this question. How many molecules in 5 moles of water? It's the same pattern as up here. but instead of dozen, we're going to write mole. 5 moles times, and we've got molecules on top. That's not enough space. Molecules on top. See, I think MOL should be the abbreviation for molecule. That's a much longer word. There's no abbreviation for molecule. And mole on the bottom. Because just like a dozen is a certain number, a mole is a certain number of things. 1 mole is how many things? 6.022 times 10 to the 23rd. It's not 12, it's that crazy number. And moles cancel out. This number is the biggest reason you have to learn scientific notation. On your calculator, you cannot put this in by punching in zeros. Your calculator won't take it. So 5 times 6.022 EE 23 equals, and my calculator is telling me 3.011 times 10 to the 24th molecules. Any questions? So going back to the bicycles, how many wheels are there in 5 dozen bicycles? 120. Because we know that each bicycle has 2 wheels. Right? We know that 1 bike is equal to 2 wheels. So we did this calculation. We got the number of bicycles. 60 bikes times 2 wheels per bike. Number of bikes cancels out, and I get 120 wheels. That one makes sense, right? Because you can think about bicycles. You can draw pictures in your mind and see how that would look. You don't want to take 60 and divide by 2 and say that 60 bicycles have 30 wheels. That doesn't work. They couldn't even be unicycles. It'd be hemicycles. Each bike has half of a wheel. Not very functional. We need to be able to do similar problems with moles and atoms and molecules. How many hydrogen atoms in 5 moles of water? Well, we already did the calculation to figure out the number of molecules. How many hydrogen atoms in 1 molecule of water? Bless you. What's the formula for water? H2O. So this is 1 molecule. How many hydrogen atoms? 2, right? There are 2 hydrogen atoms per 1 molecule of water. The chemical formula tells us that. How many oxygen atoms are in 1 molecule of water? 1. How many seats are on 1 regular bicycle? 1. So if I want to know how many hydrogen atoms in 5 moles of water, I already got the number of molecules here. I can just keep going and say, well, there's 2 hydrogen atoms per 1 molecule of water. Then the molecules cancel out. I still have that number in my calculator, times 2. It'll be 6.022 times 10 to the 24th hydrogen atoms. Any questions? Dimensional analysis really helps when doing problems like this. A lot of times you've got the numbers, but you're not sure, do I multiply or do I divide? If you learn how to look at the units, dimensional analysis, the units will tell you what to do. It really is beautiful. And if it hasn't made sense to you yet, and I know there are some of you, it just hasn't quite clicked yet, keep going. Keep trying. Okay, let's do a couple more problems. Calcium is the most abundant metal in the human body. A typical human body contains roughly 30 moles of calcium. That's the backstory for this problem. We don't really need that. They just throw that in there. Not sure why. Determine the number of calcium atoms in 30 moles of calcium. That's the real question. So moles, number of atoms, these are units. This really is a unit analysis, a dimensional analysis problem. So let's write a path first. What are we asked to find?
Calcium atoms.
The number of calcium atoms, right? So I'm trying to find calcium atoms. And what is the unit